Alright, this is my first test, which is controlling a DC motor and a wheel to move. Alright, so what we have here is a DC motor, an Arduino, and an L293D, and my sketch. So with my L293, an L293D is an H bridge, and so here I have a wheel which is attached to a DC motor. So my L293D is sending pulses to my DC motor and telling it to move in one direction for 2 seconds and move in another direction for 2 seconds. I have my Arduino here. That's my microcontroller, and what's making all of this happen is my sketch. And so here I'm using pins 10 and 11 on my Arduino, and so those are PWM pins, and I'm allowed from my sketch here. My first function here is saying pin mode, motor, pin R1 output is telling it that I'm sending pulses from pin 10 and 11. My void loop function, which is right over here, is basically telling the motor to move with my L293D, basically telling my motor to move one way for 2 seconds and then another way for 2 seconds. And so that's the whole program. Yeah. Okay, so here we have an ultrasonic sensor, and here we have the Arduino. This is our sketch, and this is a diagram I will be showing you in just a second. Alright, so this is the ultrasonic sensor. What it can do is measure the distance. So there is a trigger and a receiver, and so what the trigger does is it shoots out a pulse, and the receiver tries to figure out how much time it takes to receive back the echo. And okay, so I'm gonna show you how my program now, basically. I'm using pin 7 and 8 on my Arduino, and so that is basically controlling the trigger and the echo of my ultrasonic sensor. Pin 7 and 8, my ultrasonic sensor. So this is my breadboard. I kept my ultrasonic sensor on my breadboard. Okay, so I'm using pin 7 and 8. This serial.begin and 9600 is basically opening this COM6 over here, this little program, and so it's telling me that how far the wall is back over there, how many centimeters it is away from the wall with the ultrasonic sensor. So if I put my hand right in front of the ultrasonic sensor, which is right over here, the ultrasonic sensor, you can see on this window that it's saying that it's 13.47 centimeters away. And if I move my hand further away, it's telling the ultra supersonic. It's telling this window that it's going farther away. It's 40 centimeters. I don't know if you can see that. And so basically, my ultrasonic sensor, my receiver on my ultrasonic sensor, measures how much time it takes over here in this section. And so what it's saying is that if you divide the time into 58, you will convert that duration into centimeters. And so here is telling me how many centimeters it takes. Alright, so this is our fourth test, and we will be testing out our infrared sensor, the behavior of an infrared sensor, what might happen when it goes over a black line or a white line. Alright, so here we have our infrared sensor, which I'm going to hold up in my hand right now, right here. We have our white and a black surface to test it out. And we also have an Arduino here, and our serial monitor and our sketch. So this is our sketch, this is our serial monitor. Okay, so I will be explaining our sketch right now. Here, in this function, we're basically making new integers called infra in L, and feeding, so that's our left infrared sensor, and we're feeding that infrared sensor into pin 4 on our Arduino, and we have infra in R, which is our right infrared sensor, and we're going to be feeding that into pin 2. Here in our setup function, we're basically telling the Arduino to get the outputs from our infrared sensor and make it an input so we can read it in our Arduino. And then in our void loop, here we're saying int L read equals digital read infra in L. So we're basically saying int L read is like an integer we're going to use for reading what our left infrared sensor red detected, whether it's a 1 or 0. And below that we have int R read equals digital read infra in R, which is basically telling us that if our right, basically telling us what our right infrared sensor detected if it's a 1 or 0. By the way, if it detects a 1, that means it detects a black line. If it detects a 0, then that means that it detected a white line. And below that we have serial.print left read, and our left read, and then we're telling if it's a 1 or 0 based on our L read, which is back here, whether it's a 0 or 1 from our left infrared sensor. So this will be going into our serial monitor. Now below that we have serial.print right read, and below that we also have serial.println R read. And so what that's saying is whatever you read based on from your right infrared sensor, what did it detect? Did it detect a 1 or a 0? And again, a 1 is a black line, a 0 is a white line. So if it detects a 1, that means our right infrared sensor is on a black line. If it detected a 0, that means our right infrared sensor is on a white line. And below that we have delay of 1000 milliseconds, which is basically 1 second. And so you notice here it says serial.print, 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 and then serial.println. So that's basically saying serial.print line. So every time this whole function goes to our serial monitor, and which is right over here, and it's printing a new line every 1000 milliseconds or 1 second from our delay. And so here we have our infrared sensor. Okay, so from what I discovered, I noticed that our infrared sensor has to be at least 1 or 1.5 centimeters away from our surface. So we're gonna test it out. Alright, see here. Alright, so you can see a light flashing on our infrared sensor. That's our serial monitor. And so when I put it over it's over a white line right now, so it should be detecting zeros. And when I put it over a black line, it should be detecting 1s on our right read. And you can notice here that our light is not flashing, whereas when you keep on a white surface, the light here flashes. Alright, that's about it for our infrared sensor, test 4.